السلام عليكم. السلام عليكم. Can you hear me well? تسمعني كويس? Okay. I will make quick revision for first lecture. We agreed this is circuit analysis and you are going to take here one midterm test, 20%. You will have two quizzes, 5% each, section 5% and the practical using one of the software like bSpice or Cox. Okay, 5%, so you'll have 20 for the coursework plus midterm 20, and the written final exam will be 110. So in all, we'll have 150. Clear? Regarding the textbook, we are going to use this textbook. It's available on the internet. You can download it free. Office hours, you can come on Mondays just after the lecture. I will be in the high voltage lab for 2 hours. Okay, high voltage lab in the corner. Okay, ground floor. We agreed you have two parts, one DC and one AC. I'm going to teach you the DC circuit analysis. Okay, what's meant by circuit and what's meant by circuit analysis later. Okay. In the first part, I'm going to teach you basic concepts, basic laws, like Ohm's law, Kirchhoff's laws, and so on. And basic concepts, what's meant by current, by voltage, power, energy, like last lecture, okay? Method of analysis and the theorems of circuit analysis. In the second part, for AC, alternating current, sine wave or cosine wave, it will be taught by Dr. Muhammad. And you will study sinusoids and phasors, AC power analysis, three-phase circuits, balanced and unbalanced. By the way, the lectures is recorded. This means you will have a presentation with a recording, like during Corona, okay? So everything will be clear with you. Sections will start. Have you started sections? You should have sections this week. They will be taught by Engineer Asma. Units and symbols. We are going to use SI units. What does it mean? Length in meter, small m. Mass in kilogram, kg, small. Time in seconds, small s. Electric current, ampere, capital A, because this is a name of scientist. Thermodynamic temperature in Kelvin, capital K. Later you'll have small k. So you have to differentiate between capital K, Kelvin, and small k means kilo. Amount of substance in mole and lumens intensity in candle. Regarding symbols, as I told you before, it's not good to write your number like that. Okay, but it's better to write it like that, where we can call it milli, not meter. Milli. So if this one in ampere, so it will be milliampere. So it will be 1 milliampere. Clear? So we have symbols in addition to units. Okay? Units, like as we agreed, current will be an ampere, voltage in volt, power in watts, but you have symbols to express it in a very friendly way. Okay? Good number. Instead of writing many zeros or big number, no, we can write small number, but we can use one of these symbols. In electrical engineering, we have all of these will be used. All of these. Okay? So starting from tera 10 to the power of 12. Okay? Giga. Okay? Mega, capital M. So now we have small m and the capital M. Kilo, small k, we have capital K, Kelvin, and so on. Also milli, small m, not meter. How can I differentiate? Normally we have here the symbol and the unit. But if you have m alone, means meter. But you can have millivolt, milliamp, and so on, milliwatts. Okay? You have micro, 10 to the power of minus 6, nano, 10 to the power of minus 9, pico, 10 to the power of minus 12, and femto, 10 to the power of minus 15. So we are working in this range. between tera to femto or pico. Clear? Okay. Regarding here the units of our quantities used in electric circuits. Power. Power means in watts, okay, or joule per second. You have here different units. What does it mean? This means you can replace joule by, for example, you can replace it by meter squared, kilogram, second. But this is unused, not commonly used. The first one is commonly used. And the second one also you must know it. But the last one, no need. Clear? A charge in coulomb, capital C, or ampere second. Volt, capital V, or watt per ampere. From where all of this, later you will know, from our revision. And so on. Capacitance in farad, or coulomb per volt. Resistance, electric resistance in ohm. This symbol, ohm, okay, or volt per amp. Electric conductance, Siemens. Today you will understand what's meant by electric conductance. Ampere per volt. But resistance, volt per ampere. So what's the conclusion? They are reciprocal to each other. Resistance is 1 over conductance, or conductance 1 over resistance. Clear? Without going through details. Magnetic flux will be in Weber. Magnetic flux density will be in Tesla, and inductance in Henry. Now let's start. Ampere. 1 ampere of current. What does it mean? We agreed, or we defined it before, the current is the time rate of change of the positive charge. So what does it mean? I is dq over dt. So the current in ampere equals coulomb second. Why? Because I is dq over dt. Or you can get q by making integration of I dt. So what is the unit here of the current? Current. How can you get the current? Ampere. It's coulomb per second. So this one should be corrected. Per second. And you know the electron charge is 1.6 10 to the power of minus 19. So to get 1 coulomb, you should have this number of electrons. So coulomb is a huge quantity. You understand? 10 to the power of 18 electrons. Okay? Volt is a measure of energy per charge, or work done per unit charge. Work done means joule. Per unit charge means coulomb. So volt means joule per coulomb. We'll explain more later. Ohm is a unit of resistance. What's meant by resistance? Voltage over current. Clear? Voltage over current. And power. What's meant by power is the product of voltage and current. So it's VI. So it will be volt ampere. Volt ampere. Clear? Clear? And we agreed in terms of current and voltage, we have different or wide band, wide range, okay? We can have up to 10 to the power of 6, this means a mega ampere, down to very small current in femtoampere in brain cells. You see, wide range. The same for voltage. We can have 10 to the power of 8. What does it mean? 100 million volts. 100 millions. Down to very small voltage in microvolt in case of antenna. And we explain the difference between power and the communications. Do you remember? Power, you need high power, but at 50 hertz. To get high power, you should have high voltage and high current, but the frequency is low, 50 hertz. For communications, they don't need high power, but they need high frequency in gigahertz. But the power, it can be in kilowatts only. In power, we need mega or gigawatts. Do you understand the difference now? That's why we have wide range for the voltage and the currents. Again, electric current, as I mentioned, is the time rate of change of the positive charge. So I is dq over dt. And we have two types of currents, DC and DC. Do you remember our course consists of two parts, I'm going to teach DC. What's meant by DC? This means the voltage and the current will be constant with time, like this figure. Clear? And AC, this means alternating current. Alternating, this means sine or cosine. And we agreed we are going to study steady state circuit analysis. What's meant by steady state circuit analysis? This means the source will remain like that forever. And for sine wave, it will remain sine wave forever. This means steady state. No change in the peak value or the frequency. Constant. What does it mean? If you have 10 cycles here, in case of AC, and you cut each one, you'll bring each one and you will put on top of each other, they will be identical. Identical, this means no change, steady state. Clear? You have DC and AC. Regarding the current, we agreed that the current is representing the flow of positive charge. But actually, electrons will move, but holes will be empty. So you will feel that holes are moving, but actually, which one is moving? Electrons. They will move opposite to the electric field, or opposite to they will be attracted to the positive. So if you have positive here, electrons will move like that. You remember? Okay. So if electrons will move like that, this means holes will move like that. So if electrons will move like that, this means the current will be opposite direction. Clear? So when I write here 5 ampere, so where is the direction of electrons? Opposite. Opposite to the arrow direction. When I reverse the arrow direction and reverse the polarity of the quantity, so negative times the negative means positive, no change. What does it mean? The right hand side figure is the same as the left hand side. Because I reversed the arrow and reversed the polarity, negative here. So it is the same. Clear? And those examples to if you have a charge, how can you get current? If you have current, how you get the charge? So in short, the current is the time rate of change of the positive charge, dq over dt, and you can get q by making a minus integration from minus infinity to t of I dt. Clear? Also, we started here some examples. And you can get the charge if you know the current and vice versa. For example, in this figure, you have the charge as a function of time. And I will ask you, determine the current graphically. So what does it mean to get the current? This means dq over dt. And we understand the differentiation of an inclined line will be constant. You understand? If not, for example, if you have y equals mx plus c, in our case, q as a function of time equals mt plus constant. This m is called the slope. Do you remember straight lines? And this slope can be negative or positive. Clear? And what's the definition of the slope? High school. M is d delta y over delta x. So y2 minus y1 over x2 minus x1. In our case, m is q2 end minus start over t2 minus t1. Can we get the slope of the first line here, inclined line? Can you see it, this one? End. So here minus 10. Start 10 divided by t2 minus t1. So 2 minus 0. So it will be 10 minus 10 minus 10, so minus 20. Minus 20 divided by 2, so we'll get minus 10. Okay? So when I draw the current, which is dq over dt, you will get constant. And the constant will be minus 10. What is the differentiation of a constant quantity? Huh? Differentiation of constant quantity, 0. Okay? The same you can do it for this inclined line. What is the slope? End minus start. So 30 minus 10, so 30 plus 10. So it means 40. Divided by 3 minus 2, which is 1. So here is the slope will be 40. It's 40. Do you understand what I'm doing here? Because if you would like to get the current from the charge, we agreed that I is dq over dt. According to this equation, if you differentiate, C is constant, M is a slope, and T is the variable. So you will get here M. So based on the value of M, you can get the current. Clear? Now, for this constant part, differentiation of a constant is 0. That's why here we'll have 0 current. The same for this part, end minus start. So it will be 10 minus 30. You will get minus 20 divided by 1. So you'll get minus 20 here. The last constant part or line segment will be constant, means 0 current. Clear? And after that, we defined the voltage or potential difference. We agreed the word potential is common in many disciplines. What's meant by potential? A function describing a certain quantity in a certain space. Function. If you add electric to this word, so it will be electric potential means voltage. So when I say, and we are in electrical engineering, clear? Even you in computers also still related to electrical, not mechanical. So when I say potential, you understand electric potential means voltage. So either to say voltage or potential difference between any 2 points. So if you have 2 points and you would like to move, assume you have here 2 points, point A, point B, and you are going to move a point charge here of 1 coulomb, okay, from this point to this point. So the amount of energy, okay, or work done per unit charge will be called the potential difference or voltage difference. So what is VAB? VAB is delta W over delta Q or dW over dQ. Clear? Work done per unit charge. Clear? So if you would like to have 1 volt potential difference, you should have 1 joule divided by 1 coulomb. Clear? Is it clear? Clear or not? And VAB, what's meant by VAB? Potential difference, end minus start. Okay? So here you'll have head of the arrow is always positive. We have arrow, so the head of the arrow is always positive, and it will be for the first digit. So A is positive, where you can find the head of the arrow. So if you draw the potential difference by arrow, head of the arrow is always positive and they are related to the first digit in the potential difference. Clear? Now, we reached also to a very important conclusion that VAB equals minus VBA. I'm using my keyboard. You have noise coming from the window. What can I do? Better? Is it better? Better or not? Okay, so we reach to a very important conclusion that VAB equals minus VBA. Okay, so if you have here, for example, 9 volts, so you can draw it like that. We agreed VAB equals 9 volts. So the first digit in the subscript will be positive. So here you will have A is positive. If you reverse the quantity sign and reverse the polarity, it will be the same. So the right hand side figure is the same as the left hand side figure. Do you understand? Because we reversed the sign and the polarity. Like current. Do you remember current? We reversed the arrow direction and the sign of the quantity. So it will be the same. Okay? Power is the product of voltage and current. That's why it's given in watts. And power is given as in watts, joule per second. So is the time rate of the energy per time rate of the energy. This means dW over dt. Okay? dW over dt. And we can replace dW over dt by dW over dq times dq over dt. This means we multiply the numerator and the denominator by dq. So what is the result? dW over dq is called work done per unit charge is called voltage, and dq over dt is called current. So power is equal to product of VI. Now, in electric circuits, you have sources and elements. Sources will generate power, delivers power, supplies power, and elements to absorb power. Okay? If, very important, if the current, can you see this part? If the current leaves the positive terminal of an element, so this power will be negative power. Like a source supplying power. Like if you have a battery and you connect a resistor, so the current will leave from positive to negative. So it will supply power. So supplying power means negative power. But if the current enters the positive terminal, this means absorbed power. So now we have new terminologies. Supplied power and absorbed power. Supplied if the current leaves the positive. Clear? Positive terminal. And if the current enters the negative terminal, it will be absorbed power. Clear? You have an electric circuit. Electric circuit means neutral, stable. Okay? So the total power supplied should equal in magnitude to the total power absorbed. As a result, summation of power should be 0. Clear? Very simple principle. Clear? Example. Let's calculate power. Okay? So here, the current 3 amps enters the positive. So this power is absorbed, positive power. So it will be 4 times 3, so it will be 12 volts. In the right-hand side figure, what did you do here? We reversed the current direction and we reversed the polarity of the voltage. So negative times the negative will be positive still. So the right-hand side figure is the same as the left-hand side figure. That's why the power in both cases is given as 12 watts plus 12 watts. Plus means absorbed. Clear? In this figure, here the current 3 amps leaves the positive. So it's a source supplying power. So it will be negative power. So minus 12. Okay, clear? And if you look to this figure, here we reversed the polarity of the 4 volts. And we reversed the direction of the current. So it will be the same. Clear? Why? Because look to this current. This current is moving like that. So the 3 amps is still leaving the positive. So the power will be supplied, negative power. Clear? So as a conclusion, power absorbed equals minus power supplied. or the power absorbed equals the magnitude of the power supplied, because power supplied is negative, or the total power is zero. Why? Because you have balanced system, balanced circuit. Example, if you have weak battery in your car, you will ask your friend to come with good battery in his car, and you connect positive with positive, negative with negative. So your car battery, which is weak, look to the current. The current I here enters the positive. So your car battery absorbing power. While the good battery, the current I leaves the positive. So supplying power. But the magnitude of both powers should equal, ignoring any losses here in the wire, because this wire always short, 3 meters, for example. And we see examples in circuit elements. We need to define circuit elements, then electric circuit, circuit analysis. At least you understand the title of your course. Circuit elements can be passive elements or active elements. Passive like R, resistance, like capacitance, and like inductance. Okay? The element itself will be called resistor, capacitor, inductor as an element. Active elements like sources, okay, like generators, like batteries, and operational amplifiers. You'll see it later. So we have passive and active. For each element, you have 2 terminals. Do you agree? Okay. Circuit analysis is the process of determining voltage across, voltage difference, voltage across, or current through, okay, the elements of the circuit. This is the meaning of circuit analysis. You need to calculate currents through or voltage across elements. Okay, of course you will have big circuit, not a simple one. But we'll start by simple circuits. Active elements, we agreed active elements means generators, batteries, and op-amp, operational amplifiers. Active elements can be voltage sources, VC, or current sources, CS. Clear? Now, new name, ideal independent source. First, let's understand what's meant by ideal. Okay? Like a battery. You can represent the battery like this one alone, without internal resistance, without. So it will be called the ideal. The practical one or actual one, you should have a resistance in series. Clear? But now it's ideal. You understand the ideal? Hello, ideal. You understand what's meant by ideal? No? In reality, in the actual case, في الطبيعة الباتري الحجارة اوكي تمثلها بالشكل ده اوكي والمفروض معاها resistance. It's impossible to explain in Arabic and you slide in English. ده الطبيعة. If you ignore this one, it will be called the ideal. Clear? So, independent source. What type of source? Voltage source. In our case, this figure for voltage source. Clear? So, what's meant by independent? This means the voltage across this source is constant, irrespective of the current drawn. You take 1 ampere or 10 ampere, but the voltage is constant. Clear now? So, ideal, this means there is no series resistance with the source. Okay? Independent, this means the voltage or current will be constant irrespective to the other quantity. If you have a voltage source, the voltage will be constant irrespective of the current drawn. If you have a current source, the current is constant irrespective of the voltage across. Clear? ideal independent voltage source. Ideal, we understand ideal. Independent voltage source. What does it mean? Like battery or like source, like this one. This one is used for AC, but the other one is used for DC. Direct current and alternating current. What's meant by ideal independent voltage source? This means it delivers to the circuit whatever current is necessary. In short, the voltage across the source is constant, irrespective of the current drawn. Take any current, but the voltage is constant. Clear? Clear? The other side, ideal independent current source. So again, ideal means there is no series resistance with the source. Independent, this means the current drawn is constant, irrespective of the voltage across the source. Irrespective of the voltage here. It can be 1 volt, 10 volt, 100 volts, but the current is always constant. This will be called ideal independent current source. What's your observation for the independent voltage source and the current source? They are represented by a circle. Circle. Okay? If you have arrow inside, this means the current source. Independent current source. If you have polarity plus minus, this means independent voltage source. For both cases, if there is no resistance in series, it will be called ideal. Clear? Clear? We have other elements of sources. These sources also ideal, but called dependent or controlled. Dependent or controlled. Okay? Sources. We agreed you have current source and the voltage source. And these dependent sources can be controlled by voltage or current. So each source can be controlled by voltage or current. Okay? So 2 times 2, you will have 4 types of sources. Clear? Clear? So we have VC, voltage source, current source. Voltage source and the current source. Each one can be controlled either by voltage or current. If it's controlled by current, I'm going to call it current controlled. Okay? Either voltage source or current source. If it's controlled by voltage, voltage controlled voltage source or voltage controlled current source. Clear? And its symbol in circuits will be diamond or rhombus. Diamond, but the independent circle. Dependent rhombus, diamond. Okay? And again, if you find the arrow inside, it will be current source. If you find polarity plus minus, it will be voltage source. Clear? I will make summary at the end. This is what's going to be used in simulation, like BSpice or Cox or any software for circuit analysis. We have 4 sources, 4 dependent sources, okay? And all of them in diamond or rhombus form, okay? If you look to this one with polarity plus minus, and here plus minus, the top one is controlled by what? Voltage. The bottom one is controlled by what? Current. So how can I call the top one? Voltage controlled voltage source, or VCVS. How can I call the bottom one? Current controlled voltage source. Okay? Clear? The 2 middle ones, both of them are dependent current sources. But this one, second one, is controlled by current. How can I call it? Current controlled current source. So triple CS. Number 3, it's a current source but controlled by voltage. So I'm going to call it voltage controlled current source. And this is the name, part name in BSpice, and this is the symbol in BSpice. Okay, maybe you will have similar in other softwares, but this is for BSpice or Spice. Clear? Why we need to have dependent sources? You didn't ask, because we agreed circles can be battery or DC or AC. Okay, but why we need dependent sources? Because we have something called transistors, op-amps, operational amplifiers, integrated circuits, ICs. All of these can be represented by dependent sources. Okay, and we have 4 types of dependent sources: 2 voltage sources and 2 current sources, and everyone can be controlled by either by voltage or current. Clear? So the dependent sources are useful in modeling elements such as transistors, operational amplifiers, and integrated circuits. Example, in this circuit, the 10i, you see, it's a dependent source. It's a voltage source, but controlled by current. Where is this current? Somewhere in your circuit, like here, the current through C. You understand? You understand? So it's controlled by current through one of the elements in your circuit. Clear? Clear? Clear or not? So again, we have independent sources represented by circles. What's meant by ideal independent voltage source? Ideal means no series resistance. Independent voltage source, this means the voltage is constant irrespective of the current drawn from the source. Ideal independent current source, again ideal, no resistance. Independent current source means the current is always constant irrespective of the potential difference across the element. Clear? Clear? When you come to dependent sources represented by diamond or rhombus, so you will have 4 voltage sources and the current sources, and each one can be controlled by voltage or current. That's why you have 4. 2 times 2. To represent what? Transistors, op-amps, and ICs. Okay? In summary, so electrical energy sources can be independent sources or dependent sources. Independent sources, like voltage sources and current sources, can be ideal or practical. Practical, you should have series resistance. Dependent sources, you have 4, as we agreed before. 2 VCs and 2 CS. And for each one, it can be controlled by voltage or current. Clear? It's coming. It wouldn't come to problems. Let's go back. Here, B4. You're asking about B4, correct? Keep quiet, please. Keep quiet. Can you close the windows? Can you help him, please? Other one, please. Can you close the door? Okay. Can you repeat, please? Keep quiet. Can you repeat? You need microphone also. So, here you have okay? So if you like to calculate the current unit, you need to multiply 0.2 times R, which is 1 ampere. Clear? 1 ampere will be out. Regarding the polarity, voltage across this source will be the same like this one. Why? Because you have wire. So here. Click. Because it's white. Now, in this example, we are going to solve it now. Again, compute the power absorbed or supplied by each component of the circuit. How many elements here do you have? We agreed elements can be active or passive, sources or like resistors, okay? So how many elements? 1, 2, 3, 4. We need to calculate the power from B1 to B4, okay? So let's start. So B1 look to the current. The 9 amp. 9 amp here leaves the positive. So the power will be positive or negative? Negative. So here you will have 5 times minus 9. So you will get minus 45. Minus means supplied. Next, B2. Here the current 9 amp enters the positive of the source. So the power here is absorbed, although it's a source, but it can absorb like battery. Do you remember weak battery, good battery? So one of them will act as a load, the other one will act as a source. Source means negative power, load means absorbing power. So now you will have here plus. So you will have 2 times 9. So we'll have plus, I write plus, watts. Here absorbed, okay? B3. In the third element, the 4 ampere enters the positive. Okay? So the power will be positive or negative? Positive. So although this one will act as a load. So here, what will be the voltage? Voltage, like the previous problem. Raise your voice. Yeah, 3 volts. Do you agree? So here's the voltage polarity. I will copy plus, minus. Okay? The current here, 4 amps enters. So you will have here 0.6 I. This is a voltage times the current. And we agreed the power here is positive. So we'll get 0.6 times I. Where is I? 5 ampere times 4. So the end result will be plus 15. Do you agree? Absorbed. B4. Yeah, it's 12, yeah, 12. Let me check numbers. 0.6 times 5, yeah, plus. So this plus 12. Thanks. B4, look to the current. The current here enters the plus. So the power will be positive or negative. So here you will have voltage is 3 times 5. You will get plus 15 watts absorbed. You can make cross check. that your answer is correct. How? Balance of power. So cross check. Summation of power should be minus 45 plus 18 plus 12 plus 15. It's a clear zero. This means it's okay. Balance of power. Is it clear? Next. We'll start chapter 2, and in chapter 2 is very important because we will introduce to you basic laws. Okay? So we'll study here Ohm's law. We'll study what's meant by nodes, loops, and branches, and the correlation between them. We'll study Kirchhoff's voltage law, Kirchhoff's current law, or KVL and KCL. We'll study series connection of resistors, and we'll study, as a result, voltage division, parallel connection of resistors, and we'll study current division, CD. We'll study delta conversion of delta connected circuits to Y connected circuits, and vice versa. What does it mean from delta to Y or Y to delta? Clear? Very important, because these are called basic laws. As a rule of thumb, basic laws can be used for simple circuits. What's meant by simple circuits? Circuits containing one source. More than one source, it's better to use one of the analysis techniques, coming chapters. Clear? So basic laws, what does mean basic laws? Ohm's law, KCL, KVL, current divider, CD, voltage divider, VD. And if needed, delta Y transformation or conversion. Clear? This can be used only if you have one source. We will define resistance. We agreed last lecture that the symbol of the resistance is like that. What's meant by resistance? Physical meaning of resistance. What's the physical meaning of resistance? Last lecture. If you have a piece of conductor, and you have potential difference, plus minus. Inside you have a piece of conductor. Conductor means plenty of electrons. That's why you have high conduction. Okay? So electrons will be attracted to the negative end. Do you agree? So electrons will be attracted to the negative end. But electrons will not move in a straight line, but they will move in zigzag paths. Okay? So electrons will move like that. What is here? What is inside this ball or this circuit? Inside the circuit you'll find electron. And electrons will jump like that. As if electrons move to the left-hand side, but holes move to the right-hand side. So the direction of the current will be like that. Why? Because I is a time rate of change of positive charge. So when I go current direction to the right, this means electrons move to the opposite direction. Clear? Now resistance. resistance. R. R will take a symbol like that. You understand what I'm saying? The symbol of resistance like that? Because the electrons will move like that. Okay? What is this R? Resistance of motion of electrons. Due to what? Number one, we agreed last lecture, impurities. Number two, collision between electrons and atoms. So we have resistance of motion of electrons. This resistance, if the length of the conductor increases, it will increase. Okay? More resistance. Okay? But if you make the cross-sectional area larger, the resistance will decrease. Okay? If you increase impurities inside the conductor, you will have higher resistance. So as a result, the resistance equals rho L over E, where E is the cross-sectional area. Okay? So this is the meaning of resistance. Resistance of electrons and the symbol Y, which is actual motion of the electrons inside conductors. As you know, classification of materials, you can have three types. You can have conductors, insulators, and in between you will have semiconductors. Clear? Based on what? Based on rho. Okay? If you have good conductor, this means the resistivity will be very low. If you have good insulator, resistivity is very high. Semiconductor, the resistivity will be in between. So as you can see here, resistivity, the unit of resistivity is ohm meter. Why ohm meter? Because R is rho L over A. In terms of units, R in ohms equals unit of rho, let's keep it unknown, meter divided by meter squared. Cancel meter with power, so the unit of resistivity will be ohms meter. Clear? As you can see here, in case of good conductors like silver, copper, aluminum, gold, you see here resistivity is very, very low. If you come to good insulating material like paper, mica, glass, Teflon, opposite, it will be plus 10, plus 12, plus 7. If you come to semiconductors, something in between, 10 to the power of minus 2. Okay? So we have something called resistivity. Ohm's law, this scientist found the following relation, that you have direct proportionality between voltage and current, V and I. And the constant here is called, constant of proportionality is called resistance. Okay? So they started like that V is proportional with I. If you remove the proportionality sign, you can put equal and the constant. This constant is the resistance. So the first law here for linear circuit. What's meant by linear circuit? The exponent here, the power of V and I is 1, linear. Non-linear will be studied in electronics. So V equals Ri. This is called Ohm's law. Will be used for linear circuits. And R is V over I. Volt per ampere will be ohms, the unit of the resistance. Clear? Clear? So the unit of R is the unit of the volt in 1 volt over 1 ampere. Will give you 1 ohm. Okay? Sometimes you have special cases. Special cases. You know, when you come to your home, for example, you will make a mistake. You will have blown out and your main switch will disconnect. Why? Because you created did short circuit. You connected the live terminal to the neutral. Later you will know this part in part 2. You did a mistake. This means you created short circuit. What's meant by short circuit? You connected both terminals together. You connected the positive with the negative. This means the voltage will be 0. Okay? But why? Because the resistance is 0. You have resistance? No, you replaced or you connected the two terminals by a wire. So the resistance between the two terminals becomes 0. As a result, the voltage will be 0. So in short circuit, the voltage is 0. We have the other side. Other side, if you will cut this wire, what will happen? The resistance will be very high, infinity. Resistance is infinity. This means the current will be 0. So we have two extremities here, two extreme cases. Okay? Short circuit, voltage is 0. Open circuit, current is 0. Clear? Clear? Short circuit. This is the terminal you connect by a wire here. So the voltage will be 0. Why? Because the resistance is 0. The other case is to open this wire. So the no flow of current. No flow of current, this means the current will be 0. Clear? Resistors in the lab or in BSpice or in MATLAB, you will find the resistors can take this shape, this symbol, or this symbol. What is the difference? The left-hand side resistors are called fixed resistors, fixed value, say 10 ohms. Okay? And it can be this shape, wire wound type, or this one carbon film type. Okay? Again, what is the difference? One big and one small. Small, this means it can withstand the low current. Big, high current. High current, this means high power. Clear? So we have fixed resistors. On the right-hand side, you will find here variable resistors. This means you can change the value. You know the volume of your radio, or okay? So you can scroll, you can change the resistance, it changes the volume. So you can have composition type or slider type, okay? And it can be like this one, variable. You have a resistor with arrow. If this arrow is on the top of the resistor, this means variable resistor. But if the arrow is horizontal like this one and just touching, will be called potentiometer. Potentiometer. Okay? So resistors, you have two types, fixed and variable. Clear? Let's take 5 minutes break. Okay? Okay, let's continue here. Regarding Ohm's law, we need to define something new called conductance. Conductance will take a symbol G. Conductance is a measure of how well an element conducts electric current. It means higher conductance means higher current. Clear? But resistance is opposite. Higher resistance means low current. The unit of conductance is called mho. Okay? Mho, ohms is spelled backward. Mho, or reciprocal of ohm. So the unit of the conductance is the reciprocal of ohm, or ohm minus 1, or Mos, okay? Or sometimes it's called the Siemens, capital S. Not a small s. Small s is second, but capital S is Siemens. 1 over ohm, okay? And conductance is the ability of element to conduct electric current. It is a measure in Siemens or Mos, okay? What is G? G is 1 over R, reciprocal of the resistance. We defined before that from Ohm's law that R is V over I. And we agreed that the conductance is the reciprocal of the resistance, 1 over G. This means G is I over V. Do you agree? So what's meant by Siemens? Ampere per volt. What's meant by Ohm? Volt per ampere. Opposite. Clear? In Ohm's law, we normally say that V equals Ri. Using conductance, I can say that I equals GV. You agree? Regarding and linearity, we agreed Ohm's law will be used for linear circuit. What's meant by linear circuit? This means the exponent here is 1. Linear. Clear? What's meant by linear circuit? This means the relation between V and I will be a straight line, and the slope is R. Do you agree? Straight line passing through the origin. Sometimes you have some elements, the relation between voltage and the current is non-linear. Non-linear. And this will be studied in electronics. So in our course, we are going to study linear circuits. Clear? We defined it before that the voltage times I is power. And you can replace V by Ohm's law as Ri. So it will be Ri squared, another form. Again, and power is Vi. Can you replace V by Ri? So it will be Ri squared. Do you agree? Clear? Can you replace I? I can replace I by V over R. So it will be V squared over R. Can we rewrite this equation in terms of G? Yes. So here it will be G V squared. Or this term can be written as I squared over G. Do you agree? So I can write the power equation in terms of voltage and current, or R and I, V and I, or I can replace R by 1 over G. Clear? That's it. Example. An electric iron draws 2 amps at 120 volt. Find resistance. So what do you have here? I have I have V. Ohm's law, you divide V over I, you will get the resistance. And it will be in ohms. Why? Because in volt and amp, so volt over amp will be ohms. So it will be 120 over 2, it will be 60 ohms. Clear? Very simple at the beginning. Again, here, how much current is drawn by a toaster? Where you have here R and you have here V. You divide V over R. So 110 over 15, you will get 7.3 amps. Direct relation, which is Ohm's law. Okay? Example. Here, what do you have? A simple circuit, a single source and a resistance. Here you have 30 volts, here you have 5 kilo ohms. What is required? Calculate I, the current, the conductance G, and power. To calculate the current, I need to apply Ohm's law. So here we applied Ohm's law. Keep quiet, please. Ohm's law, you divide to get current. V equals Ri. So to get I, it will be V over R. So here, V is 30. Do you agree that the voltage here, or the voltage source, will be applied to this resistor? Do you agree or not? Hello? If you have a battery and you connect a lamp to this battery, do you agree that the voltage across the lamp will be the same as the voltage of the battery? Do you agree? Why? Because you have wires. Very small wires, negligible resistance. Okay? So the voltage here will be 30 volts and resistance is 5 kilo ohm. Remember kilo. So 30 over 5, 10 to the power of 3, you will get 6 milliamps. From where milli? from here. Okay? To get conductance, G is 1 over R. Okay? Here 10 to the power of 3 again in the denominator, so it will be milli. And the unit will be Siemens, capital S. It's correct to write 1 minus 1. It is the same. Or like that. MOS. It's correct. Regarding power, I can multiply VI. This is one form. Or I squared R. Or V squared R. So you have 3 forms of power. Okay? All of them will get the same answer. But what's wrong? If you did a mistake in I, your answer will be wrong. So I prefer to use here this one. Why? Because the voltage is given. So it should be correct. So if you make a mistake in current, no mistake here in using the last equation. Let's start. Power is VI. So V is 30, I is calculated 6 milliamp. So 30 times 6, you'll get 180, but remember 10 to the power of minus 3, which is converted to, again, milliwatts. Clear? Can you get it by other method? Yes, as Ri squared. R is 5 kilo. So R is 5 kilo, and I is 6 milli squared. Okay? So you end up with the same result. Or V squared G. V is 30, so it will be 30 squared times G, and G is 0.2 millisiemens. Milli, 10 to the power of minus 3. So you'll get the same answer. So as you can see here, you can get the power by 3 formulas. Okay? Another example. Similar, but instead of having a voltage source, here we have a current source. Similar. Calculate V. So we are going to apply Ohm's law. So V is Ri. R is given 10 kilo. 10 times 10 to the power of 3. So you end up with 10 to the power of 4. Do you agree? Times I is given. Do you agree that the current of the current source will be the current through the resistor? Do you agree? Okay. So here you will have 3 milli. Milli means 10 to the power of minus 3. So you end up with 30 volts. Next, calculate the conductance. G is 1 over R. 1 over R, so it will be 1 over 10 kilo. We can write like that, by the way. And the kilo can be converted up to milli. So it will be 0.1 10 kilo. So it will be 0.1 milli Siemens. Can we rewrite this one in a better form? Yes, by using micro. This means you multiply by 10 to the power of 6. So it will be 100 micro Siemens. Finally, calculate the power. Power, different forms. Okay, let's use this form. I prefer this one here. Why? Because the current is known. So it will be Ri squared. Okay. R is 10 kilo. Again, 10 to the power of 4 times I squared 3 times 10 to the power of minus 3 squared. So it will be 9 10 to the power of minus 6 times 10 to the power of 4. So you end up with 10 to the power of minus 2. Okay? 9 to the power of minus 2. So what's meant by this one? Let's write this one like that. Watts. We don't refer to this form. It's correct. So it's better to put it in milliwatts multiplied by 10 to the power of 3. So it will be 90 milliwatts. Clear? Very simple example. Clear? Next, a voltage source of 20 sine by T volt is connected across 5 kilo ohm resistor. Find the current through the resistor and the power dissipated. So calculate I and P. I by Ohm's law is V over R. So you divide this equation or this term by 5 kilo. 5 kilo will be translated later to milli. Okay, so just you divide by 5 and the end result will be in milliamp. So 20 sine over 5, it will be 4 sine by T milliamp. Regarding power, you multiply VI. Okay, VI. This means you multiply this term in volt by this term in milli, remember milliamp. Volt times milliamp, you will get milli in terms of power, milliwatts. That's it. So you multiply, you will get 20 times 4, you will get 80 sine squared by T milliwatts. Clear? The same for the practice problem. No need to spend time. You have the answer, so you can do it at home. Now, we need to understand the difference between branches, nodes, and loops. Branch. A branch, this means part of the circuit that contains one element. In this circuit, how many branches, how many elements do we have? Branches means elements. Because each branch will have one element. So 1, 2, 3, 4, 5. Okay? So how many branches do we have? 5. Do you agree? How many nodes? What's meant by node? We agreed that each element at the beginning can be represented here by 2 terminals. Imagine I will have another element and they are connected here. You see now the circle becomes solid. Okay? And another element here. So this point or this terminal which is common between any 2 or more elements will be called node. Node. So how many nodes do we have here? You can count 1, 2, 3, 4, 5, 6, 7, 8. But this is not correct. Why? Because all of these can be replaced by one node. Do you agree? But in terms of better engineering drawing, we draw it like that. But actually it's one node. The same for the bottom one. Bottom one also one node. So in all, how many nodes do we have? 3 only. Clear? So branches, we agreed we have 5 branches. Nodes, we have how many? 3. You agree? You agree so far? Loops. What's meant by loop? It should be a closed path. Okay? A closed path. How many loops do we have here? How many? 3. So loops also will be 3. Loops. Branch means element. How many elements? This means the number of branches equal the number of elements. Nodes, remember, if you have wire connecting many nodes, they can be replaced by wire. It means no elements in between. It should be replaced by one node. So in this circuit, we have 5 branches, 3 nodes, and 3 loops. Do you agree? This is the same, so you can go through it. As I told you, actually, the circuit is like the right-hand side. But to have a better engineering drawing, easy to understand, so we normally draw it like the left one. But remember, all of these can be replaced by one node. All of these can be replaced by another node. So at the end, we have only 3 nodes. 3 nodes, 5 branches, and 3 loops. 3 loops. You agree? So a loop is called a closed path. It should be closed. Okay? And very important, a loop is said to be independent if it contains at least one branch which is not part of the other loops. Independent. Okay? Very important, because later we'll solve the equations. Number of loops should equal to the number of equations or number of unknowns. In this case, you can have only one solution. Do you remember? Number of equations equals the number of unknowns. So when you solve, you will get only one solution. Okay? 2 or more elements are in series if they exclusively share a single node. Do you remember my sketch before? So if you have 2 series elements, they will share only one node. Okay? In the middle. 2 or more in parallel. 2 elements in parallel. So connected to the same 2 nodes. I will explain. Look here. This is one element. And here we have another element. They are connected in series. Do you see this node? Common. Do you agree? What else? The current will be the same. Do you agree? But if you have 2 elements connected in parallel, you see now this terminal and this terminal. So how many common nodes? How many common nodes here? 2. What else? The voltage will be the same. The voltage will be the same. So for parallel connection, they will have 2 common nodes and the voltage will be the same. For series connection, they will have one common node, but the current will be the same. Clear? Back to the same circuit. We agreed that you have how many branches? Branches means the elements. How many? 1, 2, 3, 4, 5. How many nodes? 1, 2, 3. A, B, C. How many loops? Closed passes? 3. If you apply in this relation, that the number of branches equals the number of loops plus nodes minus 1. So loops is 3, nodes is 3. So 3 plus 3, 6 minus 1, you will get 5, which is the same as the number of branches. Clear? Example. In this circuit, how many identify which elements are in series and which one are in parallel? In addition, determine the number of branches, nodes, and your circuit. How many branches here? 4. How many nodes? Let's count. This is 1. This is 2, which is the same like this one. So this one will not be counted because it's the same. And this one. So how many nodes? 3. How many branches? 4. How many loops? 2. Can you apply the formula? Number of branches equals to number of nodes plus loops. So 3 plus 2, 5 minus 1, you will get 4. Correct? What is next? Identify which elements are in series and which elements are in parallel. Series, this means again, they will have a common node and the current will be the same. Parallel connection, this means they will have 2 common nodes and the voltage will be the same. So again, which elements here are in series and the others in parallel? It's very simple. Raise your voice. Yes. Okay, so now the voltage source and the 5 ohms, they are in series, while the 6 ohms and the 2 ampere source, they are in parallel. Do you agree? No? Series and parallel. You have 2 elements. For each element, you have 1, 2 unique elements. If you connect them like that, so this will be replaced by 1 node. Do you agree? So series connection, one common node. What else? The current will be the same. I will be the same. But if you have connection, this one, can you see? Because of the screen. Now let's connect 1 and 2 like that. So this is 1 node. Okay? This means I can deploy it like that. One node. The same here can be drawn like that. Another node. So they have 2 common nodes and the voltage will be the same. Okay? So in this here, we agreed that 10 volt source and the 5 ohms are connected in series, because the current is the same. While the 6 ohms and the 2 amp source, they are connected in parallel. The voltage will be the same. Okay? In this example, can you count the number of branches, loops, and nodes? Then decide or define which elements are connected in series and which elements connected in parallel. Quickly, please. How many branches? Branches means elements. Quickly. How many nodes? Yes. You have 3. This is 1, 2, and all of these to 3 nodes. Okay? How many loops? How many loops? 3. 3 loops. Okay? Some of you will consider this is also a loop. And the outermost one will be a loop. This is correct, but they are already included in the other 3 loops. So don't repeat. Don't repeat. Clear? So we have 3 loops, 3 nodes, and so n plus l minus 1. So 3 plus 3. 6 minus 1 will get 5. 5, which is the number of branches or number of elements. Which elements here are connected in series and which elements are connected in parallel? See, 1 and 2 ohms, they are connected in parallel. 2 common nodes. And the 10 volt source and the 4 ohms, they are connected in parallel. See? And the combination of the 1 and 2, the combination of this part, they are connected in series with the 5 ohms. Okay? Because later you can replace 1 and 2 equivalent by 1 resistor. So the combination. I'm talking about combination. Kirchhoff's law, we have two laws here, one for the current and one for the voltage. In short, we have KCL, Kirchhoff's current law, and the KVL, Kirchhoff's voltage law. For current, summation of the current I will be 0. What does it mean? This means if you have a node, and at this node you have many currents, some of them are in, some of them are out. So here, let's have something like that. So if you have here, for example, I1, I2, I3, I4, I5. So at any node, the summation of the current will be 0. What does it mean? You can consider the currents entering the node positive, the others will be or in the opposite direction, leading will be negative. Or vice versa. It doesn't matter. What does it mean? Equation 4. If you consider the current leaving the node, like I1, I2, will be positive. So I have to write I1 plus I2. Minus opposite direction. I3, 4, 5 are entering the node. So this will be negative. Very simple. This is based on the conservation of the charge. The charge should be the same for the currents entering and currents leaving. Or in short, the currents leaving, sum of the currents leaving is equal to the sum of the currents entering. It is the same. Is it clear? Clear or not? The same for voltage. Similar. Summation of the voltage is 0. Wait on a closed loop. Closed loop. So if you have, for example, a source, V1, and 2 elements, nothing. Now you have closed loop, and you have 2 elements. And I put polarity like that. V2, or let's write V0, V1, and here V2. So to apply KVL, you should have a closed loop. To apply KCL, you should have a node or part of a circuit. I will explain later. But let's start simply like that. If you apply KCL, you should have a node. To apply KVL, you should have closed loop. And you can write it as mathematically V0, I will start by V0. Look to the polarity, negative, positive. But here, positive, negative, opposite. Opposite means I will write V0 minus V1 minus V2 equals 0. Clear? Clear or not? So to apply KVL, I should have closed loop, and sum of the voltages on a closed loop should be 0. Okay? You can start like that or start like that. It doesn't matter. Like here. You can consider the currents leading positive and the entering negative or vice versa. It doesn't matter. The most important summation of the current is 0 at a certain node. Clear? Really? Let me explain here. So we have two laws, KCL, Kirchhoff's current law, and KVL, Kirchhoff's voltage law. They are very important laws. For KCL, it's based on the charge conservation law. Okay? The same charge in is the same as the charge out. Okay? Imagine you have pipelines. Okay? Pipelines. Imagine you have a pipeline, and this pipeline is split into two pipes. If you have here a certain flow, Q1, you should have here Q2 and Q3. Ready? Such that Q1 should equal to Q2 plus Q3. This is the conservation of the charge. Based on this one, we created this law. Summation of the current with this law. Okay? So to apply KCL, I should apply it at a certain node, considering the currents in positive and the currents out negative, or vice versa. It doesn't matter. Let's apply here in this diagram. Okay, we can start by current entering positive, for example. So I have I1 plus I3 plus I4 minus I2 minus I5 equals 0. Or, in other words, I1 plus I3 plus I4 equals to I2 plus I5. Do you agree? The same. Do you agree? Kirchhoff's voltage law, okay, and also KCL. Let's continue with KCL first. As I told you, KCL can be applied at a node or part of the circuit, but you should draw like a closed path around this part. Can you consider it as a node? Okay, because we define the node as a connection between two elements. Two terminals of the element will be connected together, forming a node. Okay? So as you can see here, we can apply KCL on a closed boundary part of the circuit. No need to apply it only at a node, but it can be on a closed boundary. Later, it will become in problems. KCL, still in KCL, if you have many, how can you read these sources? These sources are called, they are current sources. Do you agree? Because you have arrow, not polarity. Which type? Dependent or independent? First part. Independent. Ideal or practical? Ideal. So here I can say I have three ideal independent current sources. Okay? Two of them, I1 and I3, up and I2 down. All of them can be replaced by one current source up. So I have to follow those up first. So I have to say the total current, or they can be replaced by I1 plus I3 minus I2. Okay? If I will reverse the direction of the equivalent current source, so I have to say I will start by the one which is similar, down. You understand? All of you would excellent last year. And again, it's performance of the response of excellent students. It means something about wrong. When I was a student here, we had 2,000 students, only 8 with excellent grade. But it seems they are very brilliant. take 3 current sources. Okay? Let's draw the current source like that. I need one different. You can apply I1, I2, I3. And here we need to replace these 3 current sources by 1. So they can be replaced by 1. It's up to you to use up or down. If I use up, so what will be the current? I1 minus I2 minus I3. If I go down, so I have to start like I2 plus I3. Fine. So if I draw it down, so it will be I2 minus I3 plus I3 minus I1. Okay? This means we apply here physically. Why? Because here we have 2 cycles. You agree that this is 1 loop? And here another loop. So you have 2 loops only. So you have 6. But all of these can be replaced by 1. Same here, all of these can be replaced by another 1. Okay? So what will be the total current here? Let's apply physically. I total equals, this is out, and this is in. So it will be I1 minus I2 minus I3. So replacing sources, this means we apply physics. Okay? Okay? This is different. Okay? KVL, we agreed to apply KVL, you should have closed loop, such that the summation of the voltages on a closed loop should be also 0. Look to the circuit here, a very simple circuit. We agreed that V naught equals V naught equals V1 plus V2, or V naught minus V1 minus V2 equals 0. Okay? The same for voltage sources. If you have parallel voltage sources, it's coming. You can replace them by 1 source. Example here. Example. Can you apply KVL here? It's a closed loop, only 1 loop. So we can say, let's start. Negative, positive. Look here. Positive, negative, positive, negative, negative, positive, positive, negative. So which one is following the source? The other source. Do you agree? Do you agree? So I can say that V1 minus V2 minus V3 plus V4 minus V5 equals 0. Do you agree? Or V1. This source assists this source in the same direction, helping. So V1 plus V4 equals V2 plus 3 plus 5, which is this equation. Clear? This means the sum of the voltage rises coming from sources equals the sum of the sources voltage drops. Voltage drops need components, resistors, but here sources. So the sum of the voltage rises equal to the sum of the voltage drops. Now, similar to this sketch, if you have voltage sources and they are connected in series, can you replace them by 1 voltage source? Yes, by applying KVL. Okay? So, if you have 3 voltage sources, V1, V2, and V3, you can replace them by one equivalent source. If you put the polarity plus minus, so plus minus, they are all of them in the same direction, heading each other. What does it mean? It's mean the voltage here VAB, remember VAB? A is positive, head of the arrow, always remember. So I can replace VAB by V1 plus V2 plus V3, algebraic sum. Algebraic sum. Sorry, this is reversible. So V1 plus V2, it's difficult for me to read and here minus V3. It's easy for you to read, but for me it's difficult. So now, and we can go another one. So, I see X likes. What is VAB? Take off the arrow. I have 400 extra students, so I'm expecting very quick answers. Positive. So if you are here, imagine here a source. Imagine here a source. This source is called VAB. This is A is positive. So if we move the negative positive, positive negative, positive negative, negative positive. So VAB equals
C plus VC plus V2 minus V1.
correct? 3 plus V2 minus V1. Clear? Why I put this source? Because to apply KVL, you should have closed loop. So imagine here, that you have a source. Okay. So all of them can be replaced by here VAB as V3 plus V2 minus V1. Okay. Can you calculate or find the voltages V1 and V2? A circuit like this one, always before going right, you have to read carefully things, then right. How can I get V1 and V2? Later we will find the many solutions, but so far we have one solution by applying the Ohm's law. Why Ohm's law? Because in Ohm's law, you can get the current here. We agree that you have only one current because it's one loop. So to get this current, I need to divide 20 volts divided by 2 plus 3. Is that connected in series? So you will get current. This current will be 20 divided by 5. So you get 4 amps. So the voltage V1, you have to check the polarity. If the current is flowing like that, so the polarity is correct. If the current is flowing like that, the polarity is opposite. Opposite. So V1 will be 2I. You agree? Ohm's law. Ri. So it will be 2I and the I calculated as 4. So it will be 8 volts. You agree? What about V2? According to the current flow, it will be down. Now this means that this one will be plus, but this one will be minus. Opposite to the polarity. Opposite, this means I must include negative sign. So V2 will be minus 3R, which means minus 12 volts. You understand? So when you consider, when you assume a current, you have to put polarity. You have to put polarity. What does it mean? Polarity, I have to say, based on this assumed current direction, the polarity will be like that. Do you agree? So here directly I will take 2I, but there I have to consider minus 3I. You understand why? Okay. This is the end result, 8 volts and minus 12 volt. Another example, let's do it. Find V1 and V2. I don't like the word find, because find, you can point that this is V1 and V2 on the circuit diagram, but calculate, determine. Okay? Calculate V1 and V2. How can we start? By applying? No, first, basic law, Ohm's law. And we'll apply also KVL at the beginning. Why? Because these two sources, they are in the same direction, assisting each other. Clear? So, you agree that, look here, the 32 volts and the minus 8 volt, they are in the same direction? Okay? Or you can replace this source by another source but reversed polarity, but it will be 8 volt. Do you remember? When we reverse the polarity and the sign of the quantity, it is the same. So actually, the two sources opposing each other. If you talk about 32 and 8, not minus 8. Minus 8, they are assisting each other. You understand? Okay. So first, let's start here by applying Ohm's law to get the current as usual. So to apply Ohm's law, we can get I. We'll assume I here. So I equals V over R. What should I write? What should I write? If you assume, based on my assumption, the current is flowing like that, so it will be 32, minus 8. 32 minus 8. Divided by the two resistors in series, do you agree? 4 and 2, so it will be 4 plus 2. So you will get 24 over 6, you will get 4 amps. Next, calculate V1. V1 is 4 again. Based on my assumption of the current, I have to put the polarity here. Polarity here. So for this one, polarity is okay. So I should write 4I. So it will be 16 volt. V2, polarity is not okay, opposite. So I should write minus 2I. So minus 8 volts. Clear? Is it clear? You can check. Look to polarity of V1 and V2. According to KVL, they are opposite. So it will be V1 minus V2. This means 16 minus 8. So it will be 24, which is this number. This number, this means I replace the two voltage sources by one. Clear? Another. Determine V naught. Where is V naught here? Is voltage across the 6 ohms. And I. Only one current because it's one loop. Okay? So based on the direction of the current, I have to put polarity. You have to spend the time on your circuit. Put polarity of the voltage difference. Okay? What is next? What's next? Apply KVL. How many unknowns do you have? How many unknowns? How many unknowns? Excellent students. Huh? Determine V naught and I. You have two unknowns. So I must have two equations. So the number of unknowns equals to the number of equations. The first equation can be formed by using KVL. Okay? So let's write here KVL. So it is required to calculate, keep quiet please. V naught, keep quiet please. Hello, keep quiet. Calculate V naught and I. We agreed. Let's start by using KVL. Again, put the polarity. Don't forget the polarity as long as you assume the current direction. Let's write. I will take the 12 source, this means a negative positive, and you have to loop. Return to the same starting point. Because you must apply KVL in closed loop. Closed loop. So if this is a starting point, make a loop and return to the same starting point. So it will be 12. I will take 12 as a positive. Negative positive. Here positive negative. So here minus, opposite. 4I. Positive negative. So minus 2V naught. Do you agree? And after that, negative positive, plus 4. And this one, 6I. Do you agree? Hello, do you agree? 6I. Can you leave? Yes. 6I. And 6I is positive. Any objection on this equation? This one equation in two unknowns. So I cannot solve it. Do you agree? I have to assume one to get the other. Assume I naught or I or V naught to get the other one. But this is not good, not correct. I have to form another equation. What is this equation? Let's simplify this one first, put it in the final form. So we'll get 12 plus 4, you will get 16. And I naught, I, and V naught. I you will have here, again? Sorry, this is negative, correct? This is negative. So minus 4I and minus 6I, so we'll get minus 10I minus 2V naught. I will call it equation 1. Equation 2, from where? As long as you have dependent source, so each dependent source will create another equation. If you look to the dependent source, how can we call it? It's a voltage source controlled by what? Hello? Controlled by what? Controlled by what? This means the equation here written on the top of the source. Quickly, how can I call it? Voltage controlled voltage source. Clear? If you look to V naught here, so V naught, ohms law, V naught, look to here please, equals what? Minus. Why? Because polarities are opposite. The red one which I wrote and the original one. Do you agree? So here it will be minus 6I. This is equation number 2. And in 1, you can write that 16 minus 10I minus plus, I'm substituting here. So plus 12I equals 0. Okay? So you end up with I equals minus 8. You agree? And in 2, you can get V naught. So V naught equals minus 6 times minus 8. You will get 48 volts. You see now? KVL will form one equation because you have only one loop, one closed loop. But the other equation can be obtained from the dependent source. For dependent sources, it must be given in the drawing. Like here, look, 2Vx. Where is Vx? The voltage across. Clear? Now I will make my assumption. I will make my assumption that the current is flowing like that. Like the previous problem, I put it by myself. Based on your current direction. The current always flows from positive to negative, higher to lower. Okay, based on this assumption, the polarity will be like that. Again, KVL. What should I write? I will take 70 minus 10 and 5, they are connected in series. So I can write 10 plus 5. I. Regarding the dependent voltage source, it's in opposite direction. Do you agree? Hello, do you agree? Hello. I'm taking this source as reference or positive. Okay? The other one opposing. Do you agree? So here minus 2Vx. Equals 0. So in this equation, 70 minus 15I minus 2Vx equals 0, and this will be equation number 1. One equation in two unknowns, like before, I cannot solve it, so I have to create another one. How can I create another one? From here. Vx, because I need to replace Vx, or replace I, as you like. Ohm's law. Have a look here. Okay, I is flowing like that. So I can say that Vx can be replaced by 10I. Do you agree? Equation number 2. And in 1, so you get 70 minus 15I minus 2, this means times 10, you get 20I equals 0. You can get I from here. It will be 35, so I will be 2 amps. I don't need I, but I need Vx, and in 2, you can get Vx. So Vx equals 10I. This means 20 volts. Finally, calculate V naught. Look to the circuit, please. V naught. V naught. Our assumed current direction and the polarity opposing the polarity of V naught. Opposing, this means minus 5I. So minus 5 times 2, you'll get minus 10 volt. That's it. Yes? Any direction. Select any direction. But the most important, when you put polarity across resistors, based on the current flow from positive to negative. Don't change it. Don't change the black ones. But you can play with the red ones based on your assumption. Clear? It's up to you. You can assume in other direction. Don't change it. Okay? But you can change with your assumption. Okay? Try to solve it again by assuming current flowing in counterclockwise. Okay? Any questions? Next lecture will solve more problems and we'll continue with this chapter. Inshallah. Thank you.